Let's look at this question. This question says a quantity x is given by epsilon naught L delta V by delta T, where epsilon naught is the permittivity of free space, L is length, delta V is potential difference, and delta T is a time interval. The dimensional formula for x is the same as that of. So I need to find what are the dimensional formulas of x. So what is x given by? Here x is given by x equal to epsilon naught L delta V by delta T, where L is length, delta V is potential difference, and delta T is time interval. So let's try to find out what are the dimensions of epsilon naught. Epsilon naught dimensions can be, we know force is given by 1 by 4 pi epsilon naught q1 q2 by r square, right? So epsilon naught, if I take it that way, I'll get epsilon naught equal to q1 q2 by f r square. So that is, if I take into units, this is Coulomb square by Newton meter square. So epsilon naught units are Coulomb square by Newton meter square. Let me put the units of this. In that way, I can write x equal to, the units of x equal to Coulomb square by Newton meter square. Length is meter. Delta V, potential difference is energy per unit charge, so joule per coulomb. So I'll write it as joule, can be written as Newton meter per coulomb, by delta T. Delta T is time interval is second. So let's see what all things we can cancel out. I can cancel out Newton meter square, 1 coulomb, 1 coulomb. So what am I left with? I'm left with coulomb per second. Now coulomb per second is what? Current. So the quantity x has to be correct. So once again, what we have done is we have written down the units of all the quantities. I didn't try to get into dimensions because if I get into dimensions, the solution will become lengthy. So I got coulomb per second, and we know that coulomb per second is correct. So the answer for this question is D, correct. Hope you could follow this. Thank you very much.